if I'm graphing this rational function, what I want to do first is I want to factor out the numerator and the denominator. So the reason I do that is so I can find one of the discontinuities. So a discontinuity is when if you follow a function, the graph of a function, if you ever have to lift up your pencil, then that is a discontinuity. So the three types of discontinuities are, you could have a hole, you could have a vertical asymptote, and you can have a horizontal asymptote. And this is usually the order in which I find each one of these. I always do the hole first, vertical asymptote, then horizontal asymptote. And then what I do is I find the x-intercept by setting the numerator equal to 0. And then at the end I plot some points. It's by plugging in values for x and seeing what the function is at those values. So if I'm doing this one right here, I'm going to factor out the numerator, so it's going to be x minus 6 times x plus 3 divided by x minus 6. So first I'm going to find the whole. So a whole is when you have a common factor on the top and on the bottom. So the whole is going to be at x equals 6, because if you plug in 6 for x, you'll have 0 divided by 0, and the x and the y at that point will be undefined. So the whole is going to be, the first discontinuity is going to be at 6 for the x value. So if I get rid of the whole to find the y value, I'm going to plug in 6 for x right here. So if I plug in 6 plus 3 is 9. The coordinate of the whole, the ordered pair of the whole, is 6, 9. That's my first discontinuity. My second one is what I'm going to do is I'm going to find the vertical asymptote. So to find the vertical asymptote, you get rid of the whole and you set the denominator equal to 0. But if you cover up this whole, these two common factors, you do not have a denominator. So the vertical asymptote is going to be not applicable. There's not going to be one. The third discontinuity is a horizontal asymptote. So in the horizontal asymptote, you want to look at the degree of the polynomial, of the numerator and the denominator. So if the degrees are the same, so in this case we have degree 2 and degree 1, they're not the same. If they are the same, you're going to take the quotient of the leading coefficients. If the degree on the top is greater than the degree on the bottom, I'm going to call that top heavy. There's not going to be a horizontal asymptote. If the degree is bottom heavy, the horizontal asymptote is going to be y equals 0. And this is because if it's bottom heavy, for example, if you had y equals x over x squared plus 2. As x increases and goes to infinity, this number is going to be closer and closer and closer to 0 because you're dividing a smaller number, the numerator, by a larger number. So those are the three situations for a horizontal asymptote. So let's look at our function. So the degree, we have 2 over 1. It's top heavy, so there's no horizontal asymptote. So after we've done our three discontinuities, I'm going to look at the x-intercept. So that you can have more than one x-intercept. So what I'm going to do is I'm going to set the numerator equal to 0. But we already know that we have at x equals 6, there's a hole, so it cannot have an x-intercept where a hole is. So my x-intercept is going to be 0 or negative 3, 0, because I'm setting x plus 3 equal to 0. So it's kind of messy over here, but I'm going to put it together with a graph. So I'm going to draw a sketch of a graph right here. And then what I want to do is I want to plot my vertical and horizontal asymptotes. So my vertical asymptote was, there was not one. Okay, my horizontal asymptote, there is not one. So there's nothing I can draw as far as the asymptotes. So what I'm going to do is I'm going to graph the remaining canceled factor, which is x plus 3. So I'm graphing that expression x plus 3. So I'm going to start at 3 and go up one, right one. And you can also put this in your calculator and verify these points on your table. So here's my rational expression. But then I have a hole at 6, 9. So I'm going to extend my graph. And then my hole at 6, 9 is you want to actually put an open circle at that point. So I have 1, 2, 3, 4, 5, 6. So right here, there's going to have an open circle. So you want to make sure to show that discontinuity. Okay, I'm going to do another example here. We'll do the function y equals 2x squared minus 5x minus 7 over x squared minus 1. So first thing I want to do is I want to simplify and factor this out. So I'm going to have y equals, factor this out. I can factor this by grouping. So I have 2x and x. I'm just getting to the answer here. So this is going to be minus 7 plus 1. Okay, so you could do that by grouping as well. So now I'm going to factor out the denominator. So it's going to be x plus 1, x minus 1. Once we factor everything out, we want to find the discontinuities. So the three different types of discontinuities are, first you want to find the hole. Then you could find the vertical asymptote. Then you're going to find the horizontal asymptote. So after you do these discontinuities, you can then find the x-intercepts and then graph your function. So the hole is where you have the common numerator and denominator factored. So x plus 1 is a hole, or x plus 1 equals 0 is where the hole is going to be. So the hole is going to be at -1, and then to figure out the y value, you take your remaining simplified expression that's already been canceled out, and you're going to plug in -1 for x. And that's going to give you your y value. So I'm going to do it over here. So it's going to be 2 times -1 minus 7 over -1 minus 1. So that's going to be -9, or -2 minus 7 is -9 over -2. So that's going to be at 9/2. So there's going to be a discontinuity, an open circle, at -1 9/2. My vertical asymptote is, after you get rid of the hole, set your denominator equal to 0. So I have my vertical asymptote is going to be at x equals 1. My horizontal asymptote is I want to look at the degree of the numerator and the denominator. So these are the same. So if you remember looking up here, if it's the same, I'm going to take the quotient of the leading coefficient. So I have a 2 and a 1. So it's going to be y equals 2 divided by 1, which is y equals 2. My x-intercept is I'm going to take my numerator and set that equal to 0. So because x plus 1 is canceled out as a whole, at -1 cannot be an x-intercept. It's got to be 7/2. So my x-intercept is 7/2, 0. So now that I have my discontinuities and my x-intercepts, I'm going to draw a sketch of my graph. So I'm going to make my coordinate plane right here. and my vertical asymptote is at x equals 1. So I'm going to draw a vertical line at x equals 1. My horizontal asymptote is y equals 2. And it's crossing the x-axis at 7/2, 0. That's 3.5. So I'm going to go to 3.5. And when I count 3.5, I'm counting from the origin. So I go 1, 2, 3.5. So I'm going to make a ordered pair right here. So I can plug in values for x in here and see what y is. But I can also put it in my calculator. So when you put it in your calculator, you need to put the numerator in parentheses and denominator in parentheses and put it all in your y1. So I put this in my calculator and I'm going to go to the table feature. So my table feature is giving me points that are -4, 3, -3, 3.25, -2, 3.6 repeating, and there's going to be an error at -1. So the reason there's an error is because that's where my discontinuity is, my hole. So at -1, the function's undefined. That's why there's a hole. And if I continue on with my table, I'm going to have 0, 7, 1, error. Okay, the reason there's an error at 1 is because of the vertical asymptote. So I'm going to do 2, -3, 3, -0.5. So I'm going to plot these points. So -4, 3 is you're starting at the origin and going left 4, up 3. -3, 3.25 is go up and a little over 3. -2, 3.6 repeating. Oops, I think I went up. Hold on here. I went up too high. Right there in that point. So this would be right here. And then -2, 3.6 repeating is going to be a little bit higher. And then -1 error. That's going to be where my hole is. So my hole is at -1, 4.5. So I want to go to -1 and go up to 4.5 and make an open circle. And then 0, 7, 1, 2, 3, 4, 5, 6, 7. So you can see this curve that's being created, and you want to make sure that you keep an open circle where the hole is. Then my second part of my graph is at 2, up a third, and then 3, or 2, this was 2, -3. I didn't write it right. So 2, -3 is going to be right here. And then I have 3, -1/2. And then we already know our x-intercept is 3.5, so it looks like this.